Right. So let's go to the first one, first tutorial file. Right. Now this tutorial is based on week 9 lecture. So remember the week 9 what we have discussed. What did we discuss in week 9? So basically, week 9 we went through this network diagrams, indexes, and the normalization. The indexes and the normalization topics are the main two topics I would say important. So I went through the indexes, and there are a bunch of questions today. We'll go through it, and then the normalization. So remember the normalization process, and normalization is the opposite of entity relationship diagrams, right? So the main idea is to build the the database with the normalized tables. That's what do you mean by the normalization. So the normalization, there's a certain process we need to go through. Remember the first step, first normalization, then the second normalization, and the third normalization. So I have explained these three steps, right? So just listen to my week 9 lecture. So I think I have explained that more in detail. Okay. Right, so let's go through this week tutorial questions. Right, so the first few questions are based on the indexes. So let's discuss the answers for these questions. Right, so the first question is asking, what do you mean by the index? Right, what is an index actually? Okay, what do you mean by the index, by the way? Can anyone answer that question? Index is basically a pointer to a data in a table. It's pointing to the data in the table, right? So we can say an index is a kind of a lookup table that we can use, or the database used, or the database search engines can use to speed up data retrieval, right? That's basically the meaning of the index, isn't it? Right? So what are the components of the index basically? Remember the components. So there are two components in the, or two columns in the index basically, right? So we have the key values, or the primary key, or whatever the key we use in that index. So the key value is there, and then the next column is the address or the pointer of that key value, right? That's it, right? And then the index is always stored in the key sequence. Remember, it's always, when you do any updates to the table, the index is automatically updated. And then yeah, that's the nature of the index. So these are the three things that you need to remember. What do you mean by the index? Index is a pointer to the data, to the table. It's a lookup table, right? To the database engine that we can use, database engine that can use to speed up the data retrieval, right? And then index contains the list of key values and the pointers, right? So if you can mention these three things, I think you will get a full, actually full marks. Okay, these three characteristics. Right. So any questions regarding the question 1? Index is, I think it's very straightforward question, isn't it? Right. Okay, so that means we can now move into question number 2. Okay. Right, so they have given this small table, right? So what they ask us to say, do is to describe the contents of an index based on the primary key of that. Now remember that the indexes, we can create indexes for any column that we like, but the database management systems automatically create an index based on the primary key when you create the table, right? So in this case, they are trying to create a table called a student table, right? And then you have a student number, first name, surname, phone, and the gender. right, so they have given the table like here, right? So so how the index looks like in this particular table. So how are you going to explain that using an example? So let's create a small index for this table. So what I will do is I'll open Excel file, right? So remember, the index contains two columns. The first column is the key value, right, and the second column contains the point or the address. Okay, so we can say actually we can say the address, or we can say the pointer. Okay, so these are the two columns we have. So let's make a small table. Okay, so this is how it looks like. Okay, so remember, the indexes always create according to the key value, right? So the smallest, in this case, the key is the student number, right? The smallest come first and the largest come the last. So the smallest in this case, let me actually take a screenshot because otherwise I need to, so let me edit, copy, and then let's put that here, paste, right? So this is the table, so this is the index. So the smallest key student number in this case is this one, 1010101. So 1010101, and the address of that is 2. Okay, so likewise you can actually, it's very easy. Then the second one is where's the second one? Here, the last one, isn't it? So 1893220. Yeah, and the address is number 6. Yes, right. Yes, Tarin, you are right. So let me explain that. And the third one is, I think this one, isn't it? The fifth one. So likewise, you can actually list all these indexes or key values and the related row number. So in this case 5, and I think the next one is the fourth one. This one, isn't it? 2, 6, 6, 1, 2, 3, 4, 5, and the 2. The address is 4, and the next one is, did I miss one thing? I think 2, 1, 2, 3, 1, 6 is missing. And the next one is this one, row number 3, isn't it? 3330. Sorry. 1, 2, 3, 4. There's the row number 3. And the next one is, the last one is the first one. 7070707. Row number is 1. That's the address. Yeah. Okay, so that is how the table. So yeah, so this is the index. This is how it looks like. So 265431, right? 265431. Yeah, so that's the answer. So sorry, would you mind, so Shay, repeating the principle in how you identify each of these indexes within the table? So the indexes, it depends, right? So in this case, now when you create a kind of a table, usually we specify the primary key, right? So each time when you specify the primary key, the database management system create an index based on that primary key column, right? That's automatic, right? We don't need to do anything, okay? But sometimes, remember, as I mentioned in that last lecture, we need to create our own indexes for some other columns other than the primary key column. It can be first name column, or it can be the last name column, or it can be something else, right? Because we need to actually speed up the data retrieval on that particular column, okay? So in that case, we need to create our own indexes. If that is the case, then the database management system will create an additional indexes based on that column, okay? So in this example, they haven't created any additional indexes. They just specify the primary key column. So that means we have an index based on this primary key. So the index now looks like this, right? Shay, does it make sense now? Okay, that's what we mean by that. Okay, right. So Tarin have a question. So if this kind of question appears, do we need to create an index and place the screenshot in the text area? Not the screenshot. You can actually write down this, right? So you can actually write down this. You just simply write these two columns. That's it. I don't want the screenshot. This is something I just put that because this is a question anyway. So this is the answer. So I need only this answer. So I don't want this one. Okay. This is just for your explanation. Okay. I need only this. So Thomas, if the primary key is a composite, how would the two key values to go on the left and the point on the right? If it is the composite and then the combination will determine, for example, if you have a student number and the first name in combined, yes, still it's the combination of this, and then of course, and then we have an additional another key value 2 column will come into place. Okay, so if you have 3 columns, then we have three key values. Okay, key value 1, key value 2, key value 3. That's how it goes. But there are some other techniques actually create these indexes. You will learn that when you go to the higher education. In this case, we don't need that at this stage. Okay, we just learning the basic principles. All right. Yes, so that's right, Tarin. Yes, it refers to the row number. Row number means the address, basically. Okay. Okay. Right. So that's the answer to this question. So do we have any questions so far? No. Okay. So let's jump to this question number 3 then. Question 3. So how can an index improve the performance of the database system or database management system? Right, so it's very easy, I guess, right? So if the table has a large number of rows, then the searching for data in a table where the index makes data retrieval very fast, right? That's the answer, okay? For example, suppose if you have a query, for example, if you think, okay, if you have a query like select asterisk where the student number is equal to 6060 or something like that. So database will determine first if there is an index based on that particular column. So in this case, yes, right? Okay, because that's the primary key column, right? So remember the primary key is always index, so there is no question about it, okay? And then the database will determine if it using the index will speed up the data retrieval. That's the second decision, because sometimes it's a Mickey Mouse table. we don't need to actually use the index at all. We can load the whole table into the memory and then find the relevant record. But imagine if you have millions of records, then of course indexes are very useful, right? That's the second decision it will make, right? So if you have many columns or many rows, then it will definitely use the indexes, right? So if the index is used, then the database management system read the index into the main memory, right? And then it searches the index. Remember the binary search mechanism I have explained last time, right? Using, slicing the index into half and half until it finds the relevant record or matching value, right? And then once it finds the matching value, it then go directly to the appropriate address of the table, right? And then read that particular row, okay? So you can see in that case, the number of reading, and we call it usually it has IO activities or input and output activities. It greatly reduced compared to sequentially reading the whole table row by row. Okay. So that's the basically idea about creating indexes, right? Because it will improve the retrieval speed of data. So if you can explain that as an answer to the question number 3, you will get full marks, right? So remember to use an example when you explain something, okay? Right, so that's the answer to question number 3. Okay, I think it's a very straightforward question. Right, the third one or the fourth question is asking how can the index be detrimental to the performance of the database system. Remember, indexes are great, they speed up the data retrieval, but at the same time, indexes can be detrimental, but there are disadvantages, right? Now the disadvantages comes if you create more and more indexes for your columns, right? So if you have 10 column table, and if you create 5 or 6 indexes, okay, then probably each index that we have created need to be maintained by the database management system, and that actually takes little time or resources, right? So every time a row is modified in your original table, right, any change value that is stored in the index will cause the index to be updated as well, right? Remember, each time when you update or do anything in the table, you need to do any all updates into the index table because you need to rearrange everything again. Okay, imagine if you have 5 indexes for 5 different columns, and if you have billions of rows in your table, so imagine the time it takes, right, to modify or update your indexes, right? So that's one of the key disadvantage of creating an index. So database professionals, as a database professionals, you need to actually determine whether you actually need an index for certain columns. Sometimes we don't need, okay? It depends. It depends on the context, okay? So that's the answer to question number 4 actually, right? So if you can mention these stuff, probably you should be okay. Okay, so that's, you will get full marks. Right, and then the question number 5. Sorry, Tarin, you have the question, so that address just refers to. Okay, yeah, storage is another key issue because when you create more and more indexes, it created. But now in the modern days, the storage is a less concern. Storage, cost of storages of indexes, but actually it matters if you have billions or trillions of rows. A bigger the table, bigger the databases, the number of indexes you create actually matters as well. But it's less important compared to the speed or the time it takes to update the indexes, right? Yeah, so storage is another concern. For small companies, probably extra cost, probably another problem. Yeah, so they need to pay for the extra storage spaces, because most of the databases now runs in a cloud-based environment anyway. Okay, yeah, that's adds some cost. Yeah, that's another key concern. Okay, so question number 5 is asking us to create a code that would create an index on the surname in the about table, right? So we already have an index based on the student number, but here they are asking us to create an index based on another column. So what is the column? Surname column, right? So how do we create an index? So what is the command to create an index? Very easy. So it's like creating a table. So we can write create index, right? That's the command. And then we need to give the name of the index, right? So actually what I will do is I go to my notepad rather than use the Excel. So I use here um, language SQL. So create index. So we can give a name. So we can say we can give any name. We can say maybe we can say student surname NBX or something like that. It's a very big index name. That's fine. And then on, right? And then we need to specify which table. So in this case, it's the student table. And then I need to tell which column of that table I need the index. So that particular, so I need create this index based on the surname column of the student table, isn't it? So what is the name of the column? Surname column. So surname. So that is how we create the index. So once you press enter, then it will create an index based on the surname. Okay. Right. So that's the answer to question number 5. Okay. Question 6. So write the code that would remove the index created in the above question. So we can drop the indexes as well, or remove the indexes. Very easy. How to remove the indexes? It's like a dropping the table, isn't it? So we can say the drop index and the name of the index. That's it. Okay. That's how we do. Right, so that's the code. I think that's a straightforward question. Right. Question number 7. Right now, in this case, write the code that could create an index on the first name and the surname in the about table. Right. So if I want to create 2 column index, so how to do that? So again, the same answer. So what I will do is I'll copy the same thing. So I can say student. So I just change the name. Something like that. So this index is based on two columns. So student table, surname, comma, sorry, first name, comma, that's what we want, right? First name. Right, so that's the index. So that's the index we create. Okay. Okay. Okay, so that's the answer to this question 7. Okay. Right. So they have actually created. So if I jump to the question number 8, so you can see in this case now they have given this big table with some extra data. So let's go through this one now. Now consider data stored in the table student. So there are a bunch of columns there: student ID, first name, surname, gender, tut group. Okay. So there is a no row ID is not the column of the table. It's merely used to weigh the reference in each row. So that's the address of that particular row, right? That's what we mean by that. Okay, so we have a couple of few questions, 3 questions here. Let's go through this. Now see here in this case, imagine we don't have any indexes. So of course we have the index check based on student ID. But let's go through this question. So which of the following insert statement would cause a duplicate primary key constraint error? I think this is very straightforward question. So they are trying to insert a student into this table. Student ID is 1, name is Fred, first name is Fred, last name is Pitt, gender is male, tut group is 4. That's what we mean by this, isn't it? So are we having any duplicate primary key error when you try to insert this row? I don't think so, right? Because the number 1 is unique, right? So we don't have any student ID with number 1, right? So this will originally get passed because there's no issue. Second part or second insert statement, how about 2856? Do we have any problem? Do we have any duplicate primary key issue in this case? Yeah, so I think we have getting a error message because there is a duplicate primary key. Row number 55, you can see here there is a 2856 already it's there. So this insert statement will get failed, right? The third one, 2912. Do we have 2912s here? 2912 now. I guess that insert statement will be successfully executed, right? There's no duplicate primary key problem. Yeah, right. So there is nothing there. So the first one will pass, second one will get fail, and the third one get pass as well. All right. I think this is a straightforward question. Nothing to do with indexes. But what I'm trying to tell is, if you have the indexes, it will speed up this insert as well, because otherwise we need to go through. Now you can see we are reading all these row IDs from top to bottom, right? So same thing will happen if you don't have any index. We need to read everything before insert any row into this table. Right, so how many rows do you need to look at to list the first name and the tut group of all the students whose surname is Cortes? Right, now in this case, since we do not have index based on the surname, right? So the database management system will actually read sequentially each and every row to find out whether the Cortes exist, right? So basically, every row need to be read. so it takes longer time. For example, if you have hundreds, thousands of rows, so we need to everything, right? Okay, that's the answer. So how many rows that had the surname Cortes in this table actually? So surname Cortes, if you go through from top, so how many rows we have Cortes? So here there is a 1 here, 5054. This one Cortes there. Is there anyone? Let's see. Yes, there's another one there. 2806, the second record. Do we have more codes? I think there are two, right? Is that two? Let me recheck. Okay, two. I think three. Yes, that I think three. Let me check where is this one. Yeah, there's one. 59 is Cortes. Okay, this one 45 there is a Cortes, and there is a one more there. Some yeah, 15 there is a Cortes. Yes, three. Yes, three. Yeah. Yes, that's right. Three. So we have three records of Cortes. Yeah. So how many rows? Three rows. Okay. So the answer for B, how many rows? Basically, every row in the table. That's the answer, because we don't have any index based on the surname. So we need the database management system will technically read every row in this table, right? Until it find the matching Cortes value. Okay, that's the answer. Okay. So if you actually go to the question 9, now they have actually created an index, right? So there are two indexes now, right? So first index, so already the first index is automatically creating, right? Anyway, that's based on your primary key value, right? That's the primary key value. And the second index is based on the surname value, right? So you can see now, now remember the index is sorted out according to, alphabetical order. So you can see the Corteses are here, right? So already listed there, so very easily we can locate the Cortes here. So three Corteses, right? Right, so the same thing, now let's go through the questions. Now if you have these indexes, the database management system use these indexes to make a decision whether we can insert these values, right? So here, if you try to insert the student number 27, so it will successfully insert, because the smallest value here in this 1072, so we can easily insert this value into the table, right? Because there is no 27 in the table index, right? So what will happen is, once we insert the 27, the index will again sorted out. The 10 to 7 will come in the top in the index, so because that's the smallest value, right? The second record, 6001, can we insert the 6001 into this table? So if I go through here, 6001, do we have 6001? I think we can, right? Yeah, so there is no issue. The 6001 can be inserted as well into this table. Once we inserted, again the index will be sorted out according to the ascending order of the key sequence, right? And without having any issue, right? The last one, the student number 9805, can we insert the 9805 into the table. So it will go through the index and see whether there is a matching row. 9, okay, there is a 9805 in address number 28. So that means the database management system will send a message saying, okay, please, you can't insert this one. There's a duplicate primary key in the table, right? Right. So it's all based on actually the index or indexes, right? So all these decisions. Right. So that's the answer for question part A. Right. So the part B, how many rows in the student table do you need to look at to list the first name and tutor group of all the students whose surname is Cortes? So now how many times we need to actually read the table to locate the Cortes? Okay. So the first read is the index, isn't it? Right. So the first read is the index into the main memory of the computer, and then what it will do is it will go through the binary search or whatever the search mechanism, and the second read is if it locate the first Cortes, it will read that particular record from the address of 15, and then it will go to the second Cortes and then the third Cortes. So basically there are 4 reads, right? 4 reads. First read is the index, and subsequent reads are the each of these 3 Cortes values in the given the address in the disk or the storage location, right? So the answer is 4 in this case. Okay, 4 rows, so 4 times. I think I have explained that in that lecture, so just listen to that. Okay, are you okay? Are you all okay with that answer? Yeah. B, is it clear? Yeah. Okay. And the last question, part C, how many rows had the surname of Cortes? Now again the same thing. So how many rows we have the surname is Cortes, we can determine. So that means if I run a kind of aggregate function, right, a count function to determine how many rows which matching Cortes, so it actually the database management system can load the index and it determined by the index by itself, right? So it will count these 3 appearances in the index. So 3, yes, easy, right? So it need not to actually load the entire table or go through the entire table. It can count based on the index itself. Okay, that's the answer to part C. Okay, right. So I don't actually ask any complex questions in your final test. So these are the things you should know. Okay, at your level, at the foundation level. Okay, right. Are you all clear about these indexes now? Are you all okay with the indexes? So these are the questions. So you don't need to go much complex issues than this. Right. Okay, now we are coming to our favorite entity relationship diagrams. Oh no, yeah, the question, yeah. Okay, now let's go through this question. Question number 10. Recursive relationship, right? So what do you mean by the recursive relationship? A recursive relationship is a relationship where the foreign key in a table referencing to the primary key of the same table. That's what we mean by the recursive relationship. Do we have the recursive relationship in this model? Yes. You can see the recursive relationship exists in here at the worker table, right? So the worker number comes again to the same table as the foreign key, right? That's the recursive relationship. Okay. Right, so that's the answer to the question number 10. Maybe you can actually, if you get a kind of this kind of a question, I don't I don't need actually to draw a diagram. Maybe if you say, right, recursive relationship means a foreign key in a table reference into the primary key of the same table, I think that's enough. You don't need to draw anything. Okay. Or maybe you can actually give a small example saying, if, for example, if there's a worker table and then the workers are supervised by some other workers, then there is a foreign key of the worker number or whatever the primary key comes back again to the same table as the foreign key. So there's a high possibility to have a recursive relationship between two rows in the same table. So you can actually mention that as a small example rather than drawing a diagram like this. Okay, so it's enough. I don't want you to spend time to draw a diagram. Right, so that's the answer to question number 10. Okay, question 11. Right, write a create table statement for the ERD below. Right, so they have given this model. So let's go through this model actually. So if I want to create the table, which table I need to create first, by the way? So there are two tables here, or two entities. Which one I need to create first? Yes, it's the branch net. Yes, that's right. Yes, why we need to create branch first? Because you can see the branch number goes to worker table as a foreign key, right? So we need to create the branch first and then the worker second. So how many foreign keys we have in the branch table? Do we have any foreign keys? No, right? Zero. How many foreign keys we have at the worker table, by the way? How many foreign keys we have at the worker table? So you can count these many ends. So we have too many ends. That means we have two foreign keys. Branch number is one, and whatever the worker number comes back again as a foreign key. So there are two foreign keys. Yeah, right. Yeah, so there are two actually, be a branch number and worker number, because worker number comes back again as a foreign key, right? Two. Right, now let's write the create table statement for this model, right? So let me go to our favorite notepad. Let me keep it. Okay. Okay, so let's write first the create table for the branch. So create table branch, open brackets, close brackets, semicolon, and then let's define the attributes. So first one is branch number, so B number. So let's take as a varchar. Varchar, maybe we can say 4. So why I use the varchar? Because in the other questions they have actually mentioned the branch number as a varchar character, so that's why I use the varchar. Okay, so varchar, and then we have the branch name, again varchar, maybe we can say 20. Then I can define the primary key. So primary keys are branch number. Yeah, so this is the first one, first table. That's very straightforward. So now let's go to this one. Create table worker. Okay, so open brackets, semicolon. So let's define the attributes first. So we have the worker number. Again, I use the worker number as varchar because they use varchars as in these examples, right? So worker number varchar. So let's say 4. And then we have surname. varchar, so let's say 10, and first name again varchar, say maybe we can put 10 as well. And then we need to be a bit careful now. So the branch number comes here as a foreign key. So I'll use the same column name because it's easy. Branch number varchar varchar 4, and then I need to be a bit careful now. The worker number comes here again as a foreign key, isn't it? So that means I can't repeat the same column name as a foreign key. I need to give a different column name in this case, right? That's totally okay. So in this case, I would say now what is the relationship here? Where some workers are supervised by other workers, right? So I would say maybe I can say as a supervisor number, right? Right. So that's 4. Okay. So now I can define the primary keys and the foreign keys. Primary key is the worker number, right? And there are 2 foreign keys, isn't it? Foreign key, let's say the first foreign key branch. So sorry, this is branch. I made a mistake. Branch number, isn't it? B number. BN. No, sorry. B number. Yeah, I made a mistake. B number, not the branch name. Foreign key, branch number. I make a lot of mistakes after Christmas holidays. Foreign key branch number references branch. And now second foreign key, isn't it? Foreign key. The second foreign key supervisor number. Yeah. Supervisor number references worker. Yeah, that's it. So that's the create table statement for the second table. Okay. Okay. So the first one is very straightforward, and this is the second one. Okay. Are you okay with this? So next, thank you for pointing me my error. So are you guys okay with this create table statements? I think it's straightforward, right? And remember, you can't specify the same column name. That's the thing that you need to be a bit careful, right? The same table, you can have only one column name. I mean, you can't repeat the same name. So I can give the same different name. Even for the branch number, actually, I can give a different name as well, as long as I specify this. I specify this statement, right? But for the simplicity purpose, we tend to use the same foreign key name, so it's easier for us to refer to tables. Right, so that's the answer to question number 11. Okay, question 11. Okay, now let's move to the question 12. Right now they ask us to write the insert statements to add the following branches. Okay, so they are adding 2 branches. Now we are adding actually the records into the branch table. So branch 1 and the branch 2. So it's pretty straightforward, just a simple insert statement. So insert into branch, branch number, comma, branch name, and then the values. The first one is the B1, and the name is the branch 1, and the second one is branch 2. Insert into branch number, branch name, values B2. The name is branch 2. Right? Yeah, so that's the branch, that's the answer, that's easy. Okay, so now they ask us to insert to add the following workers, so worker details. Right now we need to actually insert some data to the worker table, so we need to be a bit careful now. Right, so let's go through one example here. In this case, the first worker number 1, or W1, that's the worker number. Surname is Smith, first name is Alan. So Smith is working at the branch number 1, that's the foreign key, and no supervisor. That means the foreign key for supervisor number is null, right? And the second one is also the same. There is no foreign key for the supervisor column, it's null. So it's perfectly okay to have null foreign keys, remember. The third example, third one, we have the Alan Smith as a supervisor. So Alan Smith is worker 1, right? So the foreign key here is W1. So likewise, we need to go through and insert the record. So let's write the insert statement. So I can write one insert and then we can copy and paste. It's easy. So insert into worker. So we have worker number. So let's define the columns first. Worker number, surname, first name, and then we have branch number, and then we have supervisor number, then the values. So let's put the values. Let me put that here. Values. The first one is worker 1. The name is surname is Smith. Simply. Surname is Smith. The Alan is the first name. Smith. Alan. And the branch number is B1. And supervisor is null. Right, so now what I can do is I can copy and paste one by one. So second one, Brown, worker number 2. Surname is Brown. First name is Sue. She is working at branch number 2. And no supervisor now, right? And then the third record, worker number 3. Grant Dow. And Hunt is working at B1, supervised by Alan Smith. Alan Smith is worker number 1. And then next one. So let me actually copy this one. The next one is Jones, Julie Jones, W4. 2D. She's working at B2, isn't it? And supervised by the Sue Brown. So Sue Brown means B, worker number 2. So likewise, I think that's straightforward. So that you can actually insert the other record easily, right? So that's the normal process. Okay, so that's the answer to the question number 30. Right, so now the question, now once we insert, so now they ask us to produce a report, right? So write a SQL statement to list the every worker and his or her supervisor. So this is the report they want, every worker. Remember, every worker. So they want actually the every worker here. So remember, the every worker means everybody appeared in the worker table, right? So if I want everybody appeared in the worker table, I can use left outer join or the right outer join rather than inner join. Yeah. So this is the report they wanted to actually produce. Worker name in the first column, supervisor name in the other column. You can see some workers doesn't have the supervisors, right? So we can have null foreign keys. So that's why we use the left outer join in this case. Okay. So let's actually write a table, also a query to produce this table. So I just simply run a select statement, right? Blah, 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 blah. So I can actually populate that later on so let's take the first table as the worker table. I need to use the alias, right? W. So I use the alias W because I'm using the same table twice. Remember, if I want to use the same table, because the first reference is the worker and the second reference is the supervisors, right? So I need to now create another logical table for the worker. So I just use the alias for that, right? So worker W, then I would say left outer join. So this case I use the same table but different alias. So let's say S this time. So S stands for supervisor. It create another copy of the worker table, a logical copy of another worker table, and this it used the alias S to refer that, right? That's the idea. Okay. So and then I need to use on how these two tables are related to each other. Okay. So the foreign key, primary key, right? So the foreign key sits in the worker table. So that is W dot, what is the foreign key? Supervisor number, right? And primary key is located at supervisor table. So S dot worker number. So that's the idea. It's easy. So now I can actually populate the select statement. So I wanted to have a worker name first. Worker names first and the supervisor names second, right? So worker names coming from the worker table, right? So W dot, let's say the first name. If I want to keep a sort of small space, I can put like this, another hyphen, and then W dot surname, right? So we can say, if I want to put a kind of a heading, I can say as worker name, right? And then comma, and then I can do the supervisor details next. So S dot first name. I want to keep a space between first name and the last name, so keep a space like this. Surname as supervisor name. Right, that's it. Right. So this is the query. Right, this is the query. Right, so that will give a report like this. Okay. Are you clear on this question, guys? Are you okay with that? So don't write the select. If you have a select statement like very complicated select, heading, columns, keep this for the last, right? So what I did is I first complete the query part. I mean the command parts, and then I came to the rest to complete. That's easy. Okay. Right. So that's the answer for that question. This one. Are you all okay with that question? Yeah. Okay. So I'm assuming everybody is okay. All right. So now, yes, Thomas. So just have a rewatch again. Okay. I think that's it. Right. So now we are moving into the normalization. Okay. So normalization questions. So the rest of these questions are normalization. All right. Now let's go through these questions. The table below is in the first normal form. Okay. Now remember the normalization process. The normalization process, if I go through here, first thing we need to actually find out if we've given a kind of a table to see whether we have any repeating groups. What do you mean by the repeating groups? That means each single cell should contain only one value, right? If you have multiple values in a one cell or one record or one row, so we need to actually get rid of that, right? Repeating groups. So so in other words, we have to actually duplicate some of these contents to separate a row with another row, okay, or the contents of the cell with another the contents of the same cell, right? So what we do is, you can see here there are some multiple attributes or multiple values exist in some of these columns. So in order to remove that, we duplicate student number, name, and the course details, so we can have a separate row for that particular instance, right? So likewise, we can do that. That's the first process, right? That's called first normal form. Okay, once you get rid of that, that's called the first normal form, right? And then from the first normal form to the second normal form, first what we need to do is we need to determine what is the primary key of this table. So this table, by the way, once you remove the repeating groups, this table we refer to as universal relation or universal table, right? So determining the primary key is that's a difficult part of the normalization process, right? That's the largest problem in the normalization. Okay. Now remember, when you determine the primary key, we need to make sure the fewest columns as possible. We need to take the fewest columns as possible. Okay. Someone can actually take the whole every column and say, okay, well, every column is a part of the primary key. No, that's not possible, right? So in this case, this example, remember student ID. If you combine the student ID and the subject code, these two columns, it actually constitute the perfect identifier because it forms a unique code for each of the rows. Okay. So that's the first thing we need to actually determine before we stepped into the second normal form. And then what we have to do is we need to find out how many parts we have in each of these primary keys. For that, we need to know what do you mean by the functional depend, because some of these columns may be depends on the parts of the primary key, some parts of the primary key, right? So that is why we need to actually think about the part key dependencies. Okay. So in this example, we have two parts in the primary key. First part is a student ID, the other part is a subject code. Okay. In some circumstances, in some circumstances, we have only one part, one primary key, or we don't have any what you call combined columns or composite columns. So in that case, our job is easy, right? So we don't need to go through this process. But in this case, since we have two parts, we need to go through get rid of part key dependency. What do you mean by the part key dependency? Because some of the columns in the universal relation probably depends on one of these parts of the primary key. Okay. For example, if you think about address is depend on the student ID, right? Student name depend on the student ID, etc., etc. So we need to remove the part key dependencies. So that is how we achieve the second normal form, right? So how to remove the part key dependencies? So we take the student ID, or we take the part of the key from the universal code, or in other words, we actually duplicate the part of the universal key or part of that particular key into another table, and then we remove all the dependents of that particular key into that table as well, right? So in this case, we duplicated the student ID to a table called student table, right? And all the dependents of the student ID removed from the universal table and recorded here, right? So student name removed, course removed, and put into the student table, right? So that means we created eventually a strong entity, right? That's what we have done. And then, say this is the example, we done that. And then the next part of the universal key is the subject code. So we go through the same process again. Subject title, convener name, convener location, everything is dependent on the subject code. So we duplicate the subject code from the universal relation to another entity. We can give a name called subject. And then we remove all these part key dependencies from the universal entity to the newly formed subject entity, right? That's what we did. Okay. Right now we have formed another kind of a strong entity from the universal. Now you can see the universal relation is shrink to 3 columns. Okay. So once we have done that, that means we have now achieved second normal form, right? Second normal form. So now we are in the second normal form. So from the second normal form, the third normal form, what is the process? Now we need to go through all these newly formed entities and see whether we have any non-key dependency. What do you mean by the non-key dependency? The column has a dependency on the other columns, right? And that the other column is not a part of the universal key or the primary key, right? So in this case, convener location, right? In the subject entity, convener location is actually depending on the convener, not on the subject, right? It depends on the convener. So that means we have part key dependency between these two columns, right? So convener location depending on the convener name. So that means again we need to remove it, right? So how can we remove it? We create another table, right? Duplicate the key and get rid of convener location from the subject entity, right? So what we have done is we create another entity called the convener, right? So we duplicate the convener name, right? Convener name here duplicated, and convener location removed from this table to this here, right? So now what happened to the subject relation? Now subject relation or subject entity now contain only 3 columns, right? Once we remove it, subject code, subject title, and the convener name. So that means we created another strong entity based on this strong entity, right? This is a strong entity we made, right? So the convener name now actually acting as a foreign key in the subject relation, right? This is the primary key, this is the foreign key, okay? Okay, so this is what we have done, okay? So now we are in the third normal forms, right? So I have explained that process using this sample. First, we create the universal entity by removing the repeating entities. So we are in the first normal form, and then we determine a universal key or the primary key for the table, right? Right, and then we determine whether we have any part key dependencies. We remove the part key dependencies one by one, right? Remove it. Right now we are in the second normal form. From second normal form to third normal form, we need to go through these newly formed entities and see whether we have any non-key dependencies. So when you remove the non-key dependencies, our structure now looks like this, right? So we have now 4 tables, right? Convener table, subjects table, probably the student table, and then this might be the enrollments table, okay? So that's what we have done last week, right? So I explained that that week, and then these are the steps you need to go through, okay? Right, having said that, now we can actually now go through, so here's the file, this one. Now we can go through these questions, okay? Right, now let's go through these questions. The table below is in the first normal form. So what do you mean by the first normal form? So they have removed all the repeating entity or repeating attributes, or sorry, repeating values, right? The key for the table is the student number and the subject. Okay, they already given us the primary key or composite primary key, right? So this is the table, okay? The table has the part key dependency, right? So what do you mean by the part key dependency? Which column has the part key dependency? How do you remove the part key dependency? And write the schema after removal of the part key dependency. Okay, now let's go through this question. What do you mean by the part key dependency? I already explained that a column that is dependent on only part of the primary key or part of the universal relation or primary key of the universal relation is called the part key dependency, right? So in this case, the universal key or the primary key is the student number and the subject code. So part key dependency is any column which is dependent on the student number or the subject code, right? So that is the answer to the part A. Okay, I think it's very straightforward. Part B, which column has the part key dependency? So student number and subject code is the primary key, right? So if you go through this, which one has the part key dependency? Right, so you can see here, actually the convener name is dependent on the subject code, right? Convener dependent on the subject they are teaching, right? So there is a part key dependency between this, the subject code and the convener, right? And also the convene office, right? So the convener name and the convene office, these 2 columns are dependent on the subject code, okay? So what we need to do is we need to remove these 2 columns from the universal relation, okay? So how do you remove the part key dependency? So what we can do is we can create a new table that contains the part key column of the universal relation, that is the subject code, right? and all the columns dependent on the part key, that is the convener name and the convener office. Okay, so let's draw that table. So very easy. So let me actually take the Excel sheet. Let me actually take another sheet. So let me take screenshot of this table. So this is the table. Edit copy. So let me paste. Right. Right. So how we remove that? So we can actually so once you so for example, okay, so we have now create another table, right? So we remove so we duplicate the subject code. So what I will do is I take this. Actually I don't need to create draw it. I just take this part. So I take the subject code, right, this column, so duplicate it and then remove these two from this table. Okay, so I can actually take this off, copy, and then I can actually place it somewhere here. Right, so this table we can call it as maybe convener table. This is my convener table, right? So once we have done that, our the main table now, or the universal table, looks like how many columns we have: student number, subject code, right, convener name, and the grade. That's all. So convener office, um, sorry, not the convener name, sorry, student number, subject code, and the grade. So these two will be removed. Okay, so the final table now looks like, so if I take these things, copy, this is my universal relation. Okay, so I just put it here, somewhere here. New, so I have subject code, paste, and I have the final, this one. Copy, paste. So this table gone. So this is how it looks like. This is the universal table. Actually, we can call this as a maybe subject table, or maybe enrollment table. It's not a good table, but this is how it looks like now. Okay, that's right. So what is the identifier for the universal table? Student number and the subject code. What is the identifier the convener table? So this is not the convener. Maybe we can call this as a subject table, actually. Much better. We can put the subject details later on, subject description, credit values, etc. So this is a subject table. Subject code is the primary key, and the universal table student number and the subject code is the primary key, right? So this is how we achieve the normalization. So that is the answer for this question. So this is, so you can write the schema now based on this, very easy. So you can say the subject table, we have subject code, comma, convener name, and convener office, right? and then the primary key is subject code. And that's the schema for this one. And then the next one is, we can actually call it as universal because we haven't given any name, so we just use the universal relation. So we have student number, subject code, and grade, right? And then we have the primary key, student number, and the subject code. And in the same time, we have the foreign key. What is a foreign key? Subject code is the foreign key, right? Because that's referencing to the here. Foreign key so you can see now this will become a kind of a weak entity, right? This is a weak entity. So this is a strong entity. Okay. So this is the final answer for this question. That's the schema. Okay. And then even if you can actually, we can see whether we have any part non-key dependent. This is second normal form. For the third normal form, now actually the question didn't ask it. We can see there is a non-key dependencies exist here as well, right? Convene office, depending on the convener name. We can remove that as well in the third normal form, right? But the question didn't ask that. So we can actually leave as is, right? Right, so that's the answer for that question. Are you guys okay with that, this question? You all okay? Yeah? Okay. All right. So let's go to the next one then. So let's go very slowly. We don't want to hurry. Okay, so that's done. So we can now move to the question number 16. All right, so the second question, this is the same thing. Is that the same thing? Subject code convener, subject code grade. Yeah, I think the same question. Yeah, so now we are in the second normal form. I think the same question. Let's go through that. The key for the universal table is student number plus the subject code. The key for the subject table is a subject code. The subject table now we have the non-key dependency, as I mentioned before, right? So we have non-key dependencies here. So what do you mean by the non-key dependency? That's the question number one. It's very easy. Non-key dependency is a column that is dependent on a column which are not part of the key for the universal relation. That's what we call the non-key dependency. So in other words, we can say column which is not dependent on either student number or the subject code is called the non-key dependency, right? That's the answer to the question A. Question B, which columns has a non-key dependency? So in this case, convener office is dependent on the convener name. So there is a a non-key dependency exists in the subject relation, right? Subject relation. So question C is asking, how do you remove the non-key dependency? So we can go through the same process. What we had to do is we can create a new table that contains the non-key column, that is the convener name. That's a non-key column, right? Because this depends on this key or this column. So that means we remove this, or we duplicate this to a new table. And then all the columns dependent on this convener name will be removed, and place in the new table, right? That's what we are going to do now. Okay. So the part C is asking us to write the schema after remove the non-key dependent. So let's do that. So I will use the same example. So now in this case, so now I need to remove this bit, isn't it? So I leave actually I leave the convener name here. So, oops. Let me put it back. Where is my this is my snipping tool. So I snip. So that's there. Okay. Convener name is there. So what I will do is I'll duplicate the convener name to another table, and then I remove the convener office from this table. So to remove to here. Actually, it's already there, right? So that's a new table, right? So we can actually call this table as our convener table, isn't it? Convener table. So now we have three tables: first table, second table, and the third table, right? So now we can actually write the schema. So for the subject table, there's no change, so we can leave this part as is. For the universal, now there is a change. Sorry, for the universal relation, there is no change. We can keep as is. For the subject table, this table now we have a change, so we have to now remove convener office. So I just remove it. But the yeah, so that's that. And now we need to create another table called the convener table, isn't it? So let's create that here. So the convener table, we have two columns: convener name and the convener office. Convener office. So the primary key for this table is convener name. That actually comes there as a foreign key in the subject table. So that means in the subject table, now we have the foreign key. That's the convener name, right? So I need to put the foreign key here now. Foreign key, foreign key convener name. References the convener. Right, so that's the schema for our for this solution, right? So there are three sub entities. A convener, that's a strong entity. Subject, again a strong entity, but this time we have the foreign key attached to that, but it's still the strong entity because subject code is unique. And then we have the weak entity called the universal entity. This one, it has a composite identifier with a foreign key subject code, actually a part of the identifier as well. It referring to the subject table, right? So that's the final schema looks like, or final structure looks like. Maybe we can actually give a name for this universal table. Maybe we can say the enroll. This is my enrollment table, something like that. And then you can change the name here as an enrollment as well. Okay. So that's how we actually do the these things, normalization. So we need to go back and forth, and change the stuff until we normalize our table structure. So compared to this, ERD approach is very easy, right? Because we are going through the other way, right? We first identify the strong entities and then identify the weak entity. But in this case, we first identify the weak entity, that means the universal relation, and then we create strong entities afterwards, right? So Thomas, would the convener table be a weak or the strong entity? The convener table definitely hang on, because we have a so in this case, let me check, because convener looks like we have the same names, isn't it? Bill Harris. In this case, we need to actually now here this is a bit now here this case we need to be a bit careful. Now here the convener name looks like we have duplicate entries, isn't it? Yeah, this looks this is actually strong entity. Yeah, strong entity, because you can see Helen Dale. When you actually convert this to a real table, we have only one Helen Dale appears, right? And one Bill Harris appears, one Sue Smith appears. So this is definitely a strong entity, right? Convener name is the primary key, right? Because this is, I just copied it from the existing table, that's why we have a duplicate entries here. But when you convert it, we don't have, right? We have one convener name and their office location, that's it. So it's a strong entity. So the convener is a strong entity, subject is a strong entity, and then the enrollment is a weak entity, because we are borrowing the subject code from the subject entity for the enrollment entity, right? Does it make sense, Thomas? Yeah, okay, right. So that's the answer to question number 17, I guess, isn't it? Yeah, no, sorry, 16. Question 16. Right. Right now, let's go to this question. So let's actually complete all these questions for this this tutorial, and then we'll take. Can we take 10 to 15 minutes break, and then we'll do the next tutorial file. Okay. Are you guys okay with that? Sounds good. Okay, Spirit. How about others? Are you okay? We'll complete these questions and then we'll take 15 minutes break and then we'll come back. Okay. Okay. All right. So let's go to the question 17. Okay. So the table below is in the first normal form. Now let's go through this. Okay. First normal form. Okay, so now this table is a very small table, right? So department code, manager name, and manager phone, and then you can see here we have only one. The primary key is very simple one. There is no composite primary key. Just the department code is the primary key, right? So there is no part key dependencies in this case, right? Because we have only one part of the primary key. Because primary key consists of only one column, so there is no part key dependencies, isn't it? Right. The table, the key for the universal table is the department code. Yes, that's the primary key. Yes, we know that. Okay, let's go through these questions. Are there any part key dependencies? The answer is no, right? The answer is no. So why it is impossible for this table to have part key dependence? Is very easy, because a primary key with only one column cannot have parts, isn't it? Right? So we cannot reduce the primary key into parts if we have only one column, right? It is impossible to have part key dependencies in this case. Okay. So that's the answer for the part B question. I think it's very straightforward. Part C, are there any non-key dependencies in there? Can you see any non-key dependencies in this table? Any non-key dependencies? Looks like there is a non-key dependency, isn't it? Right? Okay. Because you can see the manager's phone actually not dependent on the department code, actually depends on the manager's name. Who is the manager? It determines the value of the phone. Okay. So that means definitely there is a non-key dependencies exist between manager phone and the manager name. Okay. So determinant in this case is the manager name, dependent is in this case is the manager phone, because manager phone dependent on the manager's name. Okay, so we have a part key dependency. That means this is in the second normal form but not in the third normal form, right? So that's how we determine it. Okay, so part D is asking us to write the schema of the two tables after removal of the non-key dependency. Okay, right. So let's write the schema so straight away because it's simple. So I use the same Excel sheet. So I use another tab. Let me make it a bit smaller. Okay. Right. So this is the table. So let's write the schema. So let's make a kind of so let's remove the manager phone from here. So how to do this? How to remove the part key dependencies? So non-key dependencies. So we duplicate the manager name and put into another table. Let's actually name that as a manager table, right? So in that manager table, we have manager name and manager phone, right? So the primary key in that table is the manager name, right? And then we have this table, we have only two columns now, department code and the manager name, right? So we can actually call this as a department table, right? So here, the department table, we have only two columns, department code and manager name. So the primary key of this table is department code, and then we have the foreign keys in it. That's a foreign key. That foreign key is the manager name. This manager name references to the primary key of the manager table. So foreign key manager name references manager table. Yeah, that's it. So we remove the part key difference. Now it's in the normalized table. So this is the normal final normalized table structure. Looks like in our database. Okay. So likewise, you need to actually, when you get a kind of an example, you should be able to know okay, whether it is in the first normal form, whether it is in the second normal form, whether it is in the third normal form, right? Determining the first normal form, very easy. If there is no repeating values, then we can determine, oh yeah, it's in the first normal form. Then the second step is we need to see whether it's in the second normal form. How you can determine the second normal form? Do we have any non-key, part key dependencies? If we have part key dependencies, then we need to remove it to achieve the second normal form, right? And then we can see whether we have any non-key dependencies. Once you remove the one non-key dependencies, then we are in the third normal form, right? So likewise, you can go step by step. Now for a Mickey Mouse table, it looks very easy. It's very easy, but for a large columns, it's very very difficult task. Okay. Actually, I'm not expecting you to have that much of complex scenarios because it's out of our syllabus. Okay. So we learn the normalization once we go to the higher education, but at this stage we just learn the principles, basics. Okay, that's the idea. All right, that's the answer to that question. So let's jump to the next question. Question number 18. All right, now it's your turn. I want your answers. The table is best described as what? A, B, C, or D. So this is the table. So what's your answer is? What is the answer? Right. Right. So how do we go through this table? Right. So let's start with first. Okay. Are there any multiple values for the cell? That is how we determine whether it is in first normal form. Okay. Do we have any repeating values? Looks like no, right? You can see each cell contains a single value, right? That means definitely this table is in first normal form, right? And the second thing is we need to see whether we are in the second normal form, right? So before that, we need to actually determine what's the primary key or the universal key for this particular table. Okay, so we have student IDs, first name, surname, subject codes, and the grades. Looks like student ID and the subject code looks like perfect primary key for this table, right? You can't take the first name and the last name. You can see their values are repeating. So therefore, student ID plus subject code looks like the primary key for this table, right? So that means we have now composite identified. Okay. Okay. Then the next thing is we need to find out whether we have any part key dependencies. Do we have any other columns depending on part of the keys? So the answer is yes, right? You can see the first name and the surname actually depend on the student ID, right? That's right. It's not actually depend on the subject code, it depends on the student ID. So therefore, definitely there are part key dependencies exist, right? If the part key dependencies exist, that means we are not in the second normal form, right? We are not in the second normal form. So the answer in this case is what? It's not A, it's not B, right? Is it not B? No, I think its answer is part B, right? It's not in the second normal form, right? So it's in the first normal form, but not in the second normal form, right? Because we have part key dependencies. So the answer is B, right? Answer is B. Are you guys okay with that? This question? So we are not in the third normal form or the second normal form because we have repeating value. We have part key dependencies. Okay. Right. So that's the answer. B is the answer. How about question 19? What's your answer? Okay, I'll give you a little time. Okay, think about this. What is the answer? I'll give you 1 minute. Think about it. What's the answer? A, B, C, or D? Anybody who can answer? That's the answer for the question 19. Is it a normalized table? No, it looks like a bit of normalized, right? Okay, Jack says it's C. Evan says it's D. Kyle says it's C. Evan says it's C. Ali says C. Who else? Where's Nat? Thomas says B. Nat, where are you? What's your answers? Tarin? Okay. Tarin says A. Nat says A. Is it unnormalized table? Does it unnormalized? What do you mean unnormalized? We have repeating values, right? So looks like we don't have any repeating values, right? So definitely it's in the first normal form, right? No repeating values. And then to find whether we are in the second normal form, we need to first determine what's the primary key of this table, right? What is the primary key of this table? Employee number, right? I think employee number, right? It's unique, right? So that means we don't have any part key dependencies, right? We don't have any part key dependencies. So that means this is automatically is in second normal form, okay? Automatically in the second normal because there is no part key dependency because we have only one part, okay? And then now the question is, well, are we in the third normal form, right? What do you mean by third normal form? How to determine whether we are in third normal form? We need to see whether we have any non-key dependencies, right? Do we have any non-key dependencies in this case? Some can argue, okay, so room number is dependent on the name. So there is a non-key dependencies between the room number and the name. But I would say this is in the third normal form because there's no point to actually remove the room number and the staff name because then in the staff table or the employee table we have on the employee number and the name, that's it. Because the ultimate objective is this kind of thing is to provide the details of each employee, which is the, I mean, this is looks like it, right? So what is the name of the employee, which room they are located, right? Maybe their contact details, etc., 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 right? So I think this table is in the third normal form, right? This is already completed normalized table, right? So the answer in this case is D, I would say, right? D, third normal form. Okay, did you understand that? Okay, so that's so it looks like. So there is no repeating attributes, there is no part key dependencies, and it appears there is no non-key dependencies as well because there is no point as to remove the room number from here because it looks like it's all in the one table, right? It depends on actually if you have more information, more attributes, then we can determine whether there is a worth for us to remove the room number and the name to another table. But in this case, I would say it's much more easier for to keep the room number and the name in the same table because it makes sense, right? Because it's related to the each employee. Okay, right. So the answer in this case is part D, the D. Okay, the normal third normal form. So I think Evan, your answer is correct. Okay. How about the next one? Question 20. Now that one is where it looks now can you answer that one? This question. What is the answer? A, B, C, or D? So Evan says it's A. How about the others? Jack says A. Yeah, the answer is, in this case, answer is, you guys are right, A, because it's unnormal. Why it is unnormalized? Can you see here in the textbook column, right? There are repeating values, so accounting and marketing. We can't have two values in the single column, right? Okay. So that means this is unnormalized table, right? We have a repeating attribute or repeating values in a single cell. Okay. So we can say it's in unnormalized. So answer is A. Right, so that's the answer to question 20. The last question, this one. A, B, C, or D. So Tarin, is your answer is B, yeah? Is that what you say for this question? Yeah, okay. How about others? So Nat says C. Jack, Thomas, Avin, what's your answer? Ali says D. Third normal form. Jack says A, unnormalized. Jack, is it unnormalized? Do we have any repeating values? Each cell contains one single value, isn't it? Right? So, you just want to go different maths. Okay. Okay. So let's go through this question, right? So are there any multiple values in a cell, right? No, I guess, right? So that means there is no multiple value, means definitely we are in the first normal form, right? Then the second question is, what is the primary key of this table, right? What's the primary key of this table? Can I take the registration number as a primary key? No, right? So you can see there's a repeating values. So there's a repeating, rego number. So rego number itself is not enough. So that means we need to definitely go with a composite key, right? Can I take the registration number with make? Probably not, right? So you can see that's not good. Primary key as well. What else? Rego number and the date. That looks good. Yes, Thomas, you're right. Yes, rego number and the date looks a better idea, right? Definitely kilometers reading is not a kind of, I don't think that's perfect, because so if I combine the date and the rego number, that means looks like the registration expiry date or something like that. So if I combine these two, looks like a perfect identifier, right? So the identifier is the rego number and the date, right? So the next question is, so we have definitely two parts of the primary key, right? So is there any part key dependencies, right? If we have the part key dependencies, that means we are not in the second normal form. If you don't have any part key dependencies, that means we are in the third normal. We are already achieved the second normal form, right? Okay, so do we have any part key dependencies? Okay. Now, if you think about the make, right, make of the vehicle, it depends on the registration number, isn't it? So definitely there are part key dependencies. So make is depending on the registration number, and probably the kilometers reading is dependent on the registration number as well. But kilometers reading, no, kilometers reading is not depending on the registration number. You can see the GPU 123 It's not depending on the rego number. Probably key kilometers readings depend on maybe the date or something like that. So there is a part key, sorry, non-key dependencies exist there as well. Yeah, so part key dependencies exist there as well. So that means this one is definitely not in the second normal form because there are part key dependencies exist, right? So the answer is the B, right? The first normal form, but not in the second normal form. Okay, so that's the answer for this question. So that's the answer.